Let's see the problem statement. Given an array of integers, calculate the ratio of its elements that are positive, negative, and 0. Okay, then print the decimal value of each fraction on a new line with 6 places after the decimal. Okay, okay, this is fine. So for example, array having this many elements, there are 5 elements, 1 2 3 4 5. So n is 5 here, and 2 positive numbers, 1 1, 2 negative numbers, -1 and -1, and there is 1 0. So result should be 2 divided by 5, which is for 2 positive numbers. 2 positive number divided by total number of elements, that is n equals to 5, that's why it is 2 by 5. For negative numbers, there are 2 negative numbers, that's why it is 2 divided by total number of elements that is inside your array. So it is again 2 by 5, and there is only 1 0, that's why it is 1 divided by 5. Fine. So we have to find out this ratio and print it in a new line. Okay, and the important thing is here 6 place after the decimal. Okay, so how to print a floating point number after its decimal point? We have to print 6 digits. Okay, that will see. So using printf, we can use percentage 0.6f. Okay, so that will see. This is very simple problem. Okay, let's find out how many number of elements are positive and how many elements are negative and how many elements are 0. Then easily we can find out the ratio. This is very simple. Let me write the code. You have to find out how many positive numbers are there. So we can say integer positive count. Initially we are making it 0. Then we need negative count also, and then 0 count. We need 0 count. Okay. Now number of positive integers that we have to find out. Then we have to find out number of negative integers, right? Then we have to find out number of zeros. This is number of zeros, then number of negative integers. So let's find out number of positive integers. So first of all, we need to iterate over each and every element of this array. Okay, here it is vector of integers, that is nothing but one integer array is there. Okay. So how to traverse a vector or an array? We can use range based formula. Okay, let's do that. We can say each number inside this vector array ARR. Then we have to find out, first let's find out all the positive numbers, then we will find out negative, then number of zeros. How you will come to know that a number is positive or negative? For positive, number should be greater than 0. This is very simple. Number greater than 0, that means it is positive, right? Otherwise we can say if number is less than 0, that means it is negative number, right? Else, if a number is neither positive or negative, then definitely number is 0. So we need to increment the 0 count. Let's do that. And here it should be negative plus plus. Here it should be positive plus plus. Fine. Okay, let me remove this part. Fine. And after getting this number of positive, negative and zeros, what we have to do, we have to find out the ratios. So directly I am using printf, and here we have to take care of decimal numbers after the decimal point. How many numbers we need? 6 digits, right? That's why 0.6f we do. And this needs to be printed in a new line, right? So let's put /n. One more number will be there. One more. And first will be what? Positive count divided by, this is positive count, divided by total number of elements. How to get number of elements inside a vector? That is by using size function, right? And likewise, we have to say negative count divided by array dot size, and 0 count divided by array size. It seems our logic is correct, okay, but unfortunately if you will run, you will not get expected output, because this positive count is one integer and array dot size is also one integer. Okay, integer divided by integer will give us integer. Okay, but we need what? We need a floating value. That's why either of these two numbers needs to be a float. Okay, one way would be we can typecast it to float like this. We can use static cast, otherwise C style typecasting also we can. Either of these two operands needs to be a float to get the result in float. Okay, fine. Let's run. Okay, then let's submit the code. Now see whether all the other test cases are passing or not. Everything is passing. Okay, do you think, is it a good idea to typecast? I don't think so. Okay, so there is some better way. If you observe, everywhere we are calculating the size, positive count divided by array size, negative count divided by array size. That means we can say positive count multiplication with 1 divided by array dot size, right? Yes, it is. So let's take one floating variable saying a multiplication factor, which will be 1 divided by array dot size. Right? If I am writing like this, again 1 is one integer, this is also one integer, array dot size also will give you one integer. Integer divided by integer will give us what? Integer. So definitely we will not get the fractional part. Okay, to get it, what we have to do? We have to say 1.0f, or simply we can say 1.f. Both of these two are fine, but it is better to write 1.0f, okay, which is more readable. So by making one of the operand float, we will get the result in floating value. Okay, now let's remove this, and here we can say multiply with the factor. Right? Let's do the same thing in all the cases. Fine. Now let's run the code and test. Okay, let's run some hidden test case. Yeah, everything is working fine. Okay, so you might be thinking, instead of using printf, can we use cout? We have to use manipulator. Okay. So that is std fixed, and then there is something known as set precision. This one. Okay. In set precision, this is not compressed code. In set precision, how many decimal points we need? 6. That's right. Let's write it down. Then the rest of the things are set. And here we need new line. Let's new line. Then after that, negative count into factor. then one more new line, then 0 count. Fine. Okay, now let's comment it out. We don't need printf now. Now let's submit the code. Yes, all the test cases are working fine. Always remember, this is important. std fixed. Okay, if I'm removing this, now see the result. Use std fixed with set precision. Okay,